Thanks, first of all, for coming out to this talk. So we're going to be talking about containerd and what does it mean for me. We're going to be looking at containerd from a slightly different use case. So we're going to look at how to build applications on top of containerd and how you can actually consume containerd. So we're going to actually look at it from a consumption point of view, not necessarily a functional point of view, but still functional because you're going to use the functions. But it's going to be more from an end user's containerd point of view. We're going to delve into some things like cri and Kubernetes at the end, and we're going to tie it all together. There's going to be 3 live demos, so hopefully everything goes well. A little bit about me. I'm from Sydney, Australia. I work for Puppet. I'm also a Docker captain. I've contributed to Linux Kit, some other things on the Moby project. My primary role at Puppet is looking at the future of what configuration management means. And what does that mean in a world where everything's becoming developer-focused? So building Kubernetes platforms, container-native applications, serverless, and things like that. So we're not going to mention Puppet Server at all, or PE, or anything like that today. I don't really have anything to do with that, except my team is the core maintainer for the Kubernetes/Docker modules, and that's because my team's the only one that's got the knowledge of how to maintain those 2 things in the company. But primarily, we build tooling around the newer stuff coming out. In this talk, we're going to have a look at what is containerd. I mean, the last talk was really good on that, so I'll skip through that fairly quickly. What upstream projects use containerd? The one thing the last talk talked about, it tied Docker and containerd together. They are loosely coupled, but they can be run separately. They're not mutually tied together. And we'll look at tying everything we've done into a real-world application, and that will take us into some of the stuff that we're working on at Puppet. So that should be what is a containerd. So I've made a spelling mistake already. What is a container? So container. This is taken from the containerd website. It's basically saying that it's a robust, simple way to run containers. It hasn't got all the bells and whistles of things like Docker does, so it doesn't have things like the image build. It has got a CLI, but that's only for like development purposes. It doesn't have things like orchestration built into it. It's just the low-level primitives that you need to run a container. Pull a container, create a namespace, manipulate a namespace, talk to the cri plugin, talk to runc, and also storage or networking plugins that you need. So we'll break it down. You get with containerd, if you just install containerd by itself, you get a CTR, which is the CLI. You get a daemon exposing a grpc API over a Unix socket, and you get protobuf specs between the components. So it's pretty low-level stuff. But it gives you the capabilities to do primitives with containers. So to break it down a little bit further from like the architecture point of view, you can see there that you've got your storage, which is your snapshot, which creates the file system, which the container tasks will then use. You've got things like content and diff there. You've got your images, you've got containers, you've got tasks and events. Tasks and execs in containerd don't necessarily map to what they do in Docker, even though the naming is similar. If you want to learn about that, I'll talk about that as we go in, because we're going to run a few exec tasks to have a look at that is. It's actually the running process, not actually execing into a process that's already running. So there's a few little stuff in the naming that's a bit confusing, but we'll go through all that. And you can see over there, you've got your runtime. So I believe that at the moment, runc support it. And there's going to be future ones coming in the roadmap for containerd I saw last week. And you can run it on any OS that you want besides Windows at the moment, I think, and Mac. So this is the latest version of the CLI. As you can see now, the 1.1.0 release was released last week or the week before. You can see there that cri is built into it now and the CLI. You can see that you've got stuff like, you can look at what plugins you've got. You can see the versions. You can look at the containers running. You can look at what namespaces are available to you. You can manipulate namespaces. You can take a snapshot of what is running. There's a whole heap of stuff you can do, tasks and that. So we'll just quickly, before we do that, containerd gives us this. It gives us OCI image spec support through runc. which is quite good. It gives us image push and pull support, network primitives for creation, modification, and deletion of interfaces. That, in the Kubernetes world, is talking to CNI. Management of network namespaces for containers to join an existing namespaces. So if there's already, you already created namespaces and things like that, you can control them in containerd. You might be wondering why I'm talking so much about namespace creation and stuff. That's usually something that's really abstracted from like end user and why I want to do it. When I get to the end of what we're actually doing at Puppet and building a Kubernetes distribution, we're actually going to be using containerd as an orchestration method between namespaces to build Kubernetes. There's also another application called Bootstrap, which is a grpc service that kind of mimics what a Kubernetes operator does, but it sits outside of Kubernetes and it talks to containerd, and the grpc interfaces talk to the multiple versions of containerd to get the Kubernetes cluster up and running. So yeah, that's why I'm talking so much about namespaces, because I'm going to get into namespace security afterwards, which was super important for what we were trying to build. So let's see a demo of just basically what containerd can give you. I was on a plane for 30 hours, so I've actually like got all this here cached in case I did typos. So we'll just do, as you can see, well, let's do CTR. There's my containerd CLI. We'll just do a quick pull, and we'll just pull Redis. I've cached this so it's quicker. And then we'll just run Redis, and there you go. You can see straight away we've got containerd running. We've pulled Redis. We're running Redis now. So as you can see there, we've got a basic example of just running an application pre-built from Docker Hub on top of containerd. That's how simple it was. I just used the pull, and then I ran it. And that's it. And as you can see, and if I wanted to, I could go and exec into it and manipulate processes and things like that. Yeah, so that's it. So it's out of the box, that's basically just containerd installed from the build, and it's up and running as a daemon, and then you can start working with it. It's fairly straightforward. So let's look at what upstream projects look at containerd. Now we've seen like some containerd primitives and how it can work and how you can use it to pull containers and things like that. So this is how other projects interact with containerd. This is old, I haven't updated it. Cri-containerd is actually in containerd now, so I need to update this slide as of last week. But you can see that there's OS storage, file system, runtimes. They can all integrate easily with containerd. And here's a really old photo of all the stuff that integrates with containerd. So you've got all the major players in the cloud ecosystem and the container ecosystem, and the underlying OSs. So containerd is basically used at the moment in Moby Linux Kit, which I'm going to get to in its own section. Kubernetes now, and LCAL, which is Linux containers on Windows. There's a really, really good talk from Docker EU. I forget the gentleman's name now, but you'll find it from Linux containers on Windows, where he starts to talk about containerd, how Microsoft are using containerd, their shim, to use Linux on top of containerd, and it's a really, really good talk. So if you're interested in Windows and running Linux containers on Windows, I definitely would check out that talk from Docker EU. So the Moby project, a project that I'm close to, I love. They're all good people there. The Moby project is made up of a whole heap of actual things to make Docker. So there's the engine itself. SwarmKit is the orchestration layer. You've got HyperKit, which is like Docker for Macs virtualization project. You've got runc and Linux Kit, which I'll talk about separately. So all these things are the Moby project, but containerd is kind of the cornerstone of all those things being built together. So the Docker engine couldn't exist without containerd. SwarmKit talks to containerd also. HyperKit doesn't matter because it's just the Docker for Mac virtualization product. Runc, again, integrates with containerd. So all these things, containerd is the cornerstone of the Moby project. And it's been broken out now in C and CF for quite a bit. This is like an older diagram again, but you can see there what it's trying to do. The grpc API, execution supervisor over the shim over runc, host storage, which is creating the Fox file system for the container to run in. You've got then tasks, which is the execution of the process within the file system, and you've got network and interface management, which would be, depending on what you're doing, it would be most likely CNI at this conference. How is containerd different from Docker? So as you can see, containerd is actually built out. All the other pieces of Docker actually talk to containerd. It's like the cornerstone, as I said before. And you can see there's all the different parts of Moby. So things like the Docker API, Docker CLI, Docker Compose, build, all that stuff is not actually in containerd, but it can talk to containerd. So if you have a look at one of the newer projects coming out of Moby, which is BuildKit, which is super awesome, being able to do asynchronous builds, it needs containerd and runc. It doesn't need the Docker engine. So that's another project coming out of Moby that containerd is like the cornerstone of, and it doesn't actually need the Docker engine itself. You can do builds without Docker. And I really like that project as well. So let's see this in action. I'm going to do a little bit of inception here and actually run Docker on top of containerd, running containerd. I'm actually running, as you can see, a slightly older version of Docker. As I know 18's out now, 18.03, but my demo didn't have time to update it. So as you can see here, I'm actually running containerd. Inside containerd, I'm running a container that's running Docker, that's running containerd. And why I'm showing you this is it's a really cool way to show an application that everyone knows on top of containerd before we go into too complex stuff like Kubernetes. It is a fully working version of Docker as well. I'll just do Docker run minus the, actually I won't do it in the background, Redis. I think it's Redis 4. Oh, I think Redis. Yeah. So as you can see now, it's just Docker. It's actually running on top of containerd, which is running containerd, which is running runc. It's really inception, but when you talk about starting to build applications on top of containerd, yes, question. Storage driver? I'm using AFUS in this particular one. So there you can see it's running, it's ready to accept connections in Redis. So as you can see, it's a fully working version of Docker. It's not like something that I've hacked in there. And when you start to have a look, if you're building applications now and you want to be container native, and you might not need a full runtime, you can start to look at containerd to build your applications on top of, because there's a really rich grpc interface there, and there's a lot of stuff you can do. So yeah, that's just a quick demo to show you Docker running on top of containerd with containerd already running again. But it's all process segmentation in namespaces. So this is why it's different to virtualization, and it allows you to do things like this. And when you start thinking about this from an architectural point of view, when you're building applications, it gives you the freedom to do so much, so much. And this is one of the things that we're working on internally, looking at how we can make our applications run more efficiently by taking up this sort of architecture. So why we actually started to look at this was we were blown away by this at DockerCon in Austin, Linux Kit, which seems really weird because we're a company that looks after configuration management, that looks after nodes. But that's not going to last forever. So we need to look at something new. What we had to look at is if we wanted to send out applications or newer things like our product like Discovery onto an on-prem, how can we do that without having to install a whole heap of containers, like sending out a compose file or something like that? How could we wrap it up into the same way across all cloud providers, so someone can just go and purchase it as an AMI? How do we look at security? Because we're shipping stuff, right? We did testing, building PE, using Packer, using Debian, which I love Debian, so this is not a bad thing about Debian. And it took 3 hours because we had to install it, install PE, then do all this security stuff to lock it down, check for vulnerabilities, and there's a whole heap of stuff there that we weren't using. So we're installing something onto an OS where we don't need all that stuff. Basically, what we needed was a kernel, a container runtime, and then we could start building stuff on scratch and then running it on top of that. That's all we needed, right? So instead of shipping this like 3 or 4 gig image to the cloud, we could have got that under like 700 megs if all we had was the kernel and a runtime. And this is where Linux Kit is so, so powerful. It actually has got the 4.14 kernel in stable now, so I made a mistake again on that. It's a super lean OS, as I'm talking about. It is just a kernel, a few things in init, and then containerd by default. It allows any runtime you want. So if you can put it in a container and you can put it in Scratch and it works on Alpine, it will boot with this kernel. The batteries are included but can be replaced, and everything's built. All services are containers. So if you're looking at everything to be container native and you want to build an OS, this is definitely what I would look at. From a security point of view, smaller attack surface. So if you're building something and you're only running containers, like you don't need SSH, you don't need a whole heap of stuff anymore. You can make it immutable. So you can make it so that only the folders that you want are mutable, things like logging or things where customers' data is. So when you start looking at building applications on top of Linux Kit, you can actually build like one of the applications we're looking at, Bootstrap, if it's on AWS, we'll actually create an EBS volume on the Linux Kit image and the customer data lives there. When we do the upgrade, that Linux Kit image gets removed, new one gets there and remounts the EBS volume because it understands which volume was there before. All the sandbox system services are sandbox. So if you want to start applying stuff like seccomp and then control groups, anything like that at the kernel level, this will allow you to do it. You can do specialized patches and configurations. So if you want to run a new kernel or some sort of patch kernel, then you just have to put it in a container. Then Linux Kit could take it. You have full control over the build. One of the things that really stood out to me this morning was talking about CD and CI. What happens if you could build your own OS in CD and CI? And it was like 700 megs, and you could ship it to any cloud. You can do that. It's right here. It's now. This has been used for a long time, so this is originally what Docker for Mac was built on, but now you can build like a Kubernetes install. All the configurations in YAML, so you don't need to learn anything new. Everyone knows YAML. That's your init system. You've got init, runc, containerd, and CA certificates. Every demo I've done today has been running on Linux Kit. When I originally wrote this talk a while back, I actually had a Mac, so running containerd on a Mac is like not that easy to get working. You have to run in a container anyway. So I ran everything in Linux Kit, and since then I've been running everything on Linux Kit. We use it a lot in Puppet, in my team, for things like CD and build process. So yeah, it's really rock solid. It's one of the projects I really like. And as I said, we only fell into this because we wanted to run stuff on top of containerd. Containerd and a kernel. That's all we needed in the OS. We didn't need all this stuff. We basically needed just like NTB and CA certificates and some really base level stuff that the OS gives you. We also were really, really conscious of security. So we wanted to remove the attack vector. And shipping software, I think that's super, super important for your customers, that you should be thinking about security before you ship. So yeah, it's all magic in Linux Kit, I think. So we're at KubeCon, right? So how does Kubernetes fall into all of this? Well, containerd and Kubernetes interact like this. So this is a new thing that I stole from Docker. So thank you, whoever done this diagram. I think it was, I'm not sure actually, but it was on their Moby blog last week. So you can see there, kubelet, cri, plugin, containerd, runc. The gentleman before spoke about a lot of services. There's not that anymore. There is actually containerd, and that's it. There's some other things you can put in there, but that's like cri-ctl. If you want to interface with cri itself to have a look at what cri is running, you can do that in containerd as well. There's a few other bits and pieces there, but you don't need anything else but the stable release from cri. It will download and install containerd. Well, it has containerd shipped with it and the version of runc. So it's super easy to get and install. And and it all works just straight from GitHub. You just have to start it all. To follow this project, I'm a big fan of this project. Why we started to use this project was we wanted to look at the leanest OS type we could to ship our Linux kit image. So one of the things that we wanted to look at is how could we get it the smallest possible that we could and just running Kubernetes. So with the Docker engine as a runtime, it was about 1.25 gigs. With cri as a runtime, it's like 700 megs. That's with kubelet installed, and it's got to pull down the control plane after that. But it only takes a couple of minutes, and it was really more powerful. One of the things that we tried to do in the modules then was we supported cri natively when it was in alpha. It's something that we wanted to do personally, so we could support it. So if you're a PE user, I am speaking about PE now, but if you're a PE user and you install Kubernetes with the module, you have cri runtime available to you. It's fully supported in our supported module there. That was some work we've done out of our team. This is our preferred method of runtime for Kubernetes is containerd and cri. So let's look at a real-world example, and I alluded to it a bit throughout this talk. If you don't know kream was something we built last year when we built the Kubernetes module, and basically it shims out Vagrant and creates a 3-node cluster. Kream stands for Kubernetes rules everything around me. So if there's any Wu-Tang fans out there, we stole it. Yes, we did. But basically, this is the newer version of it. So there's no Puppet. It's all Go now. The Kream client acts as what would be an upstream application consuming the platform. It sends a blob over grpc of what the Kubernetes cluster needs to look like. Bootstrap then gets that and looks at what it needs to pass on. It speaks to containerd over a grpc socket, and then it speaks to the kubelet container and passes the information as a process exec into kubelet and configures it. Once that information's been configured, the grpc kubelet then Bootstrap then looks at kubelet and says, "Oh, cool, you're configured." It then starts a grpc process with the next node, and in the Kream client there'll be a whitelist of IP addresses that it's expecting, so just no one can hop on at that time of creation. And then it will talk to the next address and configure the cluster and make sure Kubernetes is all up and running. Bootstrap also, this is highly in development at the moment. It also speaks to AWS and understands about EBS volumes and being able to map to do upgrade process and things like that around the day 2 of management of Kubernetes. So we have a product, a puppet called City Pipelines for Containers, which at the moment can install Kubernetes only on GKE. This looks like it will be a solution that we could install Kubernetes on for our customers on any cloud platform. If the customer doesn't want to use a hosted solution and prefers to use an image that they can put inside a VPC instead of using something like AKS or the hosted version of Kubernetes. So it gives them a lot of different options if they want to use it. This also, we're testing it on VMware. Depending on what VMware host you have and things like storage speed and like that, you can have some bad performance. If you've got a really high-end kit, it actually works fairly well. But yeah, so this is what we got to. So the whole point of everything we went through was, can we build a Kubernetes distribution that we can ship to our customers and look after things like security, upgrades, a whole heap of stuff like that that an end user cares about. The whole cornerstone of everything that this is built on is containerd. So we kind of stole the operator model from Kubernetes, and then we've kind of built our own grpc interfaces between Bootstrap, and it's the same sort of ethos that the operator has, except we're using containerd as the orchestration method. Yeah, because it's got all the primitives we need, the logic's in the Bootstrap application. So I can show you a quick demo. As I said, this is in heavy development at the moment. So I'll just show you like Linux kit again. So as you can see there's Kubernetes running 1.10.0, and we can get all the pods. Oh, I need to do all namespaces. They can go, it's just running. So you can see there. So the other thing that Bootstrap's going to be doing it's not doing now is handle things like etcd configuration across the host for HA, and a few other things like that. But yeah, so this is what all this talk of building applications on top of containerd was going to, like, how could we build our own Kubernetes distribution, and how could we orchestrate Kubernetes when Kubernetes is not there yet. And containerd was what we looked at, and we built an application that replicates what, as I said, what an operator does, but it uses containerd. And then once that the cluster is seen as stable and it's up and running, Bootstrap actually rips itself down. So it doesn't run anymore because it has access to things like security credentials. It has access to other things inside Kubelet. So once it deems itself as the cluster's in a stable state and set up compared to the blob that was sent to it originally with the cluster configuration, it no longer exists, which again was something that we wanted to do because we wanted to be security focused. And I think with all that, just a light bit of topic and demo running through containerd. I have questions if anyone wants to ask them. Yep, just want. Oh, we'll just wait for the microphone. Gentleman's coming.
Check, check. How is Linux Kit different from CoreOS, for example?
So, like CoreOS, I don't have I don't have the tools to build it from scratch. So I'm still got a whole stuff. Not saying that CoreOS is bad, but I'll put a quote against that because Red Hat bought it. No, we love Red Hat, we do. It was. So yeah, so CoreOS was like the first iteration of what this looks like, but this gives me so I can build this from scratch, like completely from scratch. So if I need to add something to the OS or remove it at time of CD, I can add it in there. So it's like fully, completely from scratch, I'm building an OS. That's the freedom that it gives me. It also allows me to build the OS in CD, which we've seen this morning was spoken so highly about. So we've got continuous integration and continuous delivery of our OSs. So if you had a look at the talk this morning, all those lines of code, we've reduced that by a whole heap because we've only got in what we need and then our code and kube. And then, so hopefully the customer can trust that OS more because, one, there's less, the attack vector is smaller, and we're taking it through all the security audits that it needs to go to before we can ship it. As I said, at the moment, this is in alpha. It's something me and my team are working on. I don't have a release date for it yet, but yeah, we just wanted to show it. We thought KubeCon was a good place to talk about it. And it's something completely different to what people expect from Puppet. So, any other questions? Cool. All right. Well, people, thank you for coming out. I mean, it was a long flight from Australia to get here, but it was worth it. And I hope you have a good KubeCon. Thank you. Actually, one thing before I go, I'd just like to thank a few people that, like, as I was a consumer, so Stephen D, Phil Etz, Justin McCormack, Illy from Weave, there's a whole heap of people that actually done the work, the hard work to build this stuff. I've just been consuming it and building some tooling around it. There's some guys on the Cry project that I like to thank. All those guys, thank you, because like all this wouldn't be possible without them. They did the hard work. I'm just a consumer and bolting it all together. So thanks to those guys as well.